Cool. So getting those fundamental concepts out of the way, we can start to talk about subsystem responsibilities. And I want to be very specific about there's a difference between power and energy. So the subsystem responsibilities for the spacecraft bus, the electrical power system must generate power to power the spacecraft for the entire mission, must store energy to power the spacecraft for the entire mission, then manage the power distribution to spacecraft subsystems, and then convert the voltage and limiting current distributed to the spacecraft components. So you can see this flow diagram of the responsibilities, where the responsibility starts at some power generation source. This can be a consumable, like one-time use, or a rechargeable source. And then there's some conversion, or you can also think of it as some engineers call it conditioning, where you have to regulate this incoming power to something that the power management system will like. This manifests in that solar panels can generate power at some voltage, but you need to convert this to some kind of voltage line in the power management and distribution. And then further, that power management and distribution conditions that voltage to varying specific points to the payload and other spacecraft loads. Typically in our CubeSat, we'll see voltage lines of 5 volts and 3.3 volts. This power conversion, power can either siphon directly to the spacecraft going down the line, or if the spacecraft doesn't need power immediately, it can be stored in some kind of energy storage. Energy storage is the accumulation of power. So remember that power is the time derivative of energy. Those two things are distinct, and I want to make sure you talk about it in the right way and think about it in the right way. And then I'll just describe the loads down here. The payload, of course, is going to require power, but the other spacecraft loads could be like the radio or the ADCS actuators and sensors. So there are a lot of different loads that the electrical power system has to support, and it all has to be regulated by the power management and distribution system. Okay, so let's walk through, if you are the electrical power subsystem lead, what are your responsibilities? So part of that is to select the power generation and/or storage technology. I just took a screenshot of the CubeSat shop. So these are different technology options for energy storage, and then here are some power generation. And we'll talk about these technologies a little bit later. The subsystem lead also has to develop schematic diagrams, printed circuit board designs, component placement on electric boards, and electric harness plan. And the subsystem lead also has to design the power conversion, distribution, and management system. So in this system diagram, you can see the different subsystems, and I'll just call out the electrical power system. You can kind of see is central to a lot of the different subsystems. It has pretty much, it's touching every different subsystem because, all of these subsystems want to be powered except for structures and mechanisms. Structures, at most, in our CubeSat, for example, the only time it needs power is to deploy the antenna. But other than that, it's really low maintenance. So of course, the electrical power system, it's touching all of these components that are active, that need some kind of electrical power. Yeah, and within itself, you can see there's this power generation subsection, and then there's the distribution and the energy storage. Other subsystem lead responsibilities include analyzing that the electrical power system can supply spacecraft bus components the proper power voltage, and current for all mission operations by managing the power budget and profile. This includes ensuring that sufficient energy is generated and stored throughout the mission lifetime. Here is an image of some satellite ground track where green is when the satellite is being lit by the sun, and then the red is when the satellite is in eclipse. And you can see this energy storage, the difference over time as the satellite passes into eclipse and then transitions out. Another responsibility is for the lead to verify electrical power system performance and analysis and testing. So you see there's 2 integration and testing engineers. They're at an electrical bench and they have an oscilloscope or some kind of signal generator. They have an ammeter. They have a lot of test procedures that they printed out, and they're most likely checking out this large system. So yeah, just making sure that the pin-to-pin connections are actually connected, that there's not like a break in a wire, that they're at the right voltage, that when the system is running, they're drawing the right amount of current, etc., etc. And then this will transition into us talking about requirements. The subsystem lead adheres to the power requirements throughout the entire spacecraft life cycle through analysis and testing.